everyone, welcome to another deep dive. This time I have with me Magnus, or just found out it's Mag, from Skip Protocol. Thanks for coming on.
Thanks for having me. Yeah.
Yeah, we'd love to we can kind of just I guess dive in. I guess how did you kind of get involved in Skip? If you want to give a so this is I guess this isn't for Skip Protocol, it's for Slinky, which is kind of your guys' new Oracle product. But would love to kind of if you could briefly, explain like what is Skip and then how did it sort of migrate over to this thing that you guys are doing now?
Yeah, sure. So Skip has generally been involved in consensus clients and MEV since its inception. We started it by building essentially the first version of a MEV aware Tendermint client called Mev Tendermint. And that was 2 years ago. And we built it originally for Terra. Obviously, Terra didn't pan out the way that we all expected, but we sort of shifted that expertise and we shifted that software into other chains in the Cosmos ecosystem. And since then, we've migrated very far from building MEV software. Now we mostly build, what we consider to be core developer tooling to help make the interchain and the sovereign, stack more powerful. And so, as part of that, we built two main things: Slinky, which we'll chat about today, which is an Oracle aggregator, and then we also build the Skip API, which is essentially a routing service on top of a variety of bridges, including IPC, to help make cross-chain transactions a lot more simple and straightforward.
Super cool. Yeah, I had actually first heard about you guys when I found out DYDX was building kind of with some of your stuff. So it's some super powerful under the hood stuff. But it's a little bit different than, most of the times I'll talk to oracles, and in the EVM world, it's usually just like a suite of smart contracts
Yeah.
that are just sort of built there and then use token incentives. You know, briefly, like how do you guys sort of differ on a conceptual level that maybe people can think of?
Yeah, I mean, at a high level, there's no smart contracts involved because the way that Slinky is built as an oracle is within the protocol itself. So it's kind of like if you encoded, an oracle into Geth or into the, Ethereum execution engine, at a higher level. That's sort of the kind of integration touch point that we have with our partners. So that does mean there's no token because it's operated and secured by the token of the chain itself. So, like for example, in the case of DYDX, like the way that would work is essentially the DYDX token is securing the chain, but then also securing the oracle. And then it's run via a sidecar process. So basically, the validators operate a sidecar that ingests prices from whatever the network expects. And then those prices are posted into the network and aggregated across the validators as part of the consensus process. So it's not done by a transaction. It's not done by sort of like any kind of external relayer entity. It's done by the validators itself by modifying their own state, their own node state to do that.
So like, yeah, maybe I'll try and draw it out as far as how I think it works, and then you can correct me if I'm wrong. I guess that might be a decent way of doing it.
Sure, sure.
Um, yeah, so like the way I understand kind of Cosmos, you have like let's say up here, this guy's the block um, proposer, and what he'll do is he'll send it over. He'll arrange like a list of transactions, one, two, and then he'll send it over to, I guess, all of the relayers, right? Or not relayers, all the other validators. And what they're going to
Yeah.
do is basically, and they're going to check off on it, right? They do a vote, and they'll say it's good, and it's here, and then from there, then they'll basically all check off on it, and then they'll do like what another round where they'll check off on the order, right? I think.
The order of the order of the transactions.
The order that's in because they do like the double checkpoints, correct? I think you have two separate votes,
Yeah.
and it
So basically, there's two rounds of consensus in there. The first one is pre-vote, where basically the validators all vote that they received the proposal, and
yep.
that the initial signs are looking bullish on the proposal, like they're it's formatted correctly, blah blah blah. And then the pre-commit step is the second round, where they essentially say, okay, I've looked at all the transactions inside of this, I've executed the state transitions, or I've at least done a soft confirmation of them, and I'm good to sort of commit this state to the chain. And
Yep.
so both require two-thirds processes, so two-thirds consensus. So both have to get through for the proposal to actually make it onto the chain.
Super cool. And so this would be, like I guess for the ETH heads, this would be similar to like these are like the attesters in Ethereum, and they're basically pushing in their attestation, and then we would basically add a block to the chain. And what you guys do, correct me if I'm wrong, I think it would be here, right? You guys add in
It's
or
actually pre-commit.
pre-commit. So down
Yeah.
here, you
Yeah.
would add in each validator also adds in some Oracle prices, right? So
hmm
so yeah, like ETH USD, Atom USD, etc. And then I'm guessing so like and then over here there's another piece where he would probably aggregate them. The proposer would do the aggregation and then publish the block.
Yeah, it's a little bit more complicated because of the delayed execution properties of Tendermint as a consensus client. So you're essentially executing the block one block after it's first proposed.
Okay.
Um, and this is, or it's finalizing, sorry, one block after it's proposed. So basically in the pre-commit step, you need two-thirds by stake weight of the votes in order to move consensus forward, right? So what we do is we use these things called vote extensions, which means we attach additional data atomically that is signed by the validators as part of their pre-commit vote. So for example, if you want to move forward in consensus, you need to take two-thirds of the votes and you need to sort of like acknowledge those two-thirds of the vote and collect them. Therefore, you also have to collect two-thirds of the Oracle data by stake weight, right? So you atomically tie the Oracle operation and the availability of that data with the ability to move forward in consensus by receiving two-thirds of the stake weight.
Right. And you
So
would all agree
yeah,
on some sort of state transition, and that would go into the block here, the new block, and then the new proposer would grab that old block.
yeah. So the proposer of the next block. So now you've submitted all the prices in the pre-commit step via vote extensions. The proposer of the next block has to include to prove that they gathered enough votes for the previous block, and this is part of this sort of like delayed finalization thing. They have to include two-thirds of the votes and vote extensions in their proposal. So they have to gather any two-thirds of the previous block's vote extensions and votes as part of making a valid proposal.
Okay. And
And
so, and so that
and then
would be where you
yeah,
do the aggregation, right?
and that's when we do well that in that next block is when we do the aggregation essentially is once the vote extensions are included in the proposal, then in the execution phase of that next block, all the prices are aggregated via a stake weighted median and then posted onto the chain via like a native module that is just available for all the smart contracts and RPCs to use. So essentially everything is on a one block delay.
Right. Yeah. Super cool.
Yeah.
Uh,
It's a
yeah.
complicated process. We have a diagram that I try to show people and they just look at it and their eyes glaze over. But this is honestly probably better than ours. But yeah.
Awesome. Yeah, no, it's cool. Because I think like like basically, and I guess I can ask some more details here about some of the specifics, but like, so do you have to, when you're voting, is this a requirement that you attach it? So,
So yeah, so that gets more into like what is the incentive mechanism for the valid or the disincentive mechanism for the validators to actually post these prices as part of their votes, right?
right,
And so you have to discourage them from not doing it, and you have to hopefully encourage them to actually do it correctly, right? So we
mostly,
have yeah, exactly. So we have multiple slashing mechanisms and reward mechanisms that can be chosen by the chain that's actually implementing this. So the first one is like an SLA type model. Basically, you can enforce on a per currency pair basis the percentage of blocks over some kind of block window that's rolling on a per block basis. It's historical. That validator or any validator must post a price for that currency pair. So for example, if you have a 80% SLA on your ETH USDC price, then every 100 blocks, every validator is evaluated to see if they posted the ETH USD price for at least 80 of them, right? And then every block that they miss that historical SLA, they are issued a small slash. And that can be, fully, of course, parameterized by the network. We have a more intense slashing mechanism for posting incorrect prices that looks a lot more similar to the Chainlink town crier model. So for folks here, probably familiar with that model, but basically there's like some kind of permissionless alerter who can essentially raise an alarm saying, okay, the whole network was wrong. And then a tertiary trusted network, like a multi-sig or a separate chain, can essentially issue a decree saying, or an issue a conclusion saying, okay, this alert was either valid or invalid, which would result in like a network-wide slash. And in our case, it would just be the validators that participated in that incorrect price. And the reward would go to the validators that were acting honestly, and then also the alerter itself. So that's like the disincentive side. And then for the incentive side, what's kind of cool about this entire Oracle process is essentially a restake. So we're taking the stake of the chain, right? We don't have our own token. So there's the stake of the chain, and it's being used to secure the Oracle. So you're essentially putting new slashing conditions on that same stake, because when we do slashing for the Oracle, it comes out of the same stake that regular consensus slashing comes from. But as part of that, you should like offer additional reward. So we're encouraging chains to sort of allocate some kind of inflation or some kind of trading fee or some kind of ongoing rewards bucket that can be allocated for the correct operation, for example, meeting the SLA and not having prices too far out of band with like the general median on an ongoing basis, right? So that there can be some kind of like recurring reward.
Yeah. Yeah, I mean that gets into more of the subjective behavior of it as far as like if you're 0.5% off, is that cool?
Yeah,
Um,
exactly.
and then you would probably need some I mean you could always use chain governance, I guess, to enforce some of it, but be ideally. And then also like this is like how do you foresee like adding changes to sort of the Oracle set? Because this has always been like the argument with like Vitalik. Like people have always said, why don't you just have an ETH US dollar Oracle or, the validators do the oracles? And he's like, well, then you have to add other ones and, which ones do we do? And it like you have to add in governance to pick which prices you're doing the Oracle on, or which sort of exchanges you're using. How do you sort of foresee that governance process going?
Yeah. So our current thesis and our current belief is that Oracle prices and Oracle price curation is best done permissionlessly, but not necessarily by governance. So what do I mean by that? Basically, like governance is a relatively like a time intensive process. And if your chain and your application is competing upon the fast addition of new markets and the correct curation of those price feeds for those markets, it's not going to be a competitive value proposition, right? So what we propose and sort of what we've worked on with DOIDX specifically is basically this mechanism called the Oracle of Oracles. And so essentially what you have there is a permission set of actors that is selected by governance and sort of voted in by governance that have the ability to sort of post their best effort mappings of new currency pairs to providers and can update and delete and, of course, add to those mappings. And then those submissions of these recommended mappings are aggregated by the proposer, and the proposer sort of selects the superset or the intersection of those to sort of like have there be essentially dedicated Oracle operators that aren't fully permissionless. They're permissioned, but they can be changed and modified and kicked out and added into uh, to sort of like curate the overall market experience.
No, yeah, because that makes sense. Because I think like definitely adding new prices is always tough. But then it comes down like this is a problem with like most companies that want like a new price feed on a chain. They'll say like, oh, they'll go to Chainlink usually, and they're like, hey, can you add a new price? And Chainlink's like, I think the minimum is like, do you have $5 million worth of liquidity on your token? And um, can you put it? If not, then we probably won't do a price feed for you. But this one, it would put it more up to, I guess, the governance as far as to pick which one would happen, right?
Yeah, I think, oracles are risky, right? And uh, like a perspective you can take on an oracle is you have to stand by every currency pair and its accuracy that is flowing through your system, right? Um, we want to hit, like, we do put our reputation behind, all of these different price feeds, but there we do allow for mechanisms by which validators and governance and chains can essentially modify the security properties willingly of certain price feeds, essentially in an attempt to execute a lot faster than other oracles can, right? So in our oracle, or in Slinky, you're able to subset the validators so that you can only have a certain percentage of the validators reporting a certain price. And you're able to create a much faster feedback loop for adding prices at some expense of, like assurances that these have gone through 6 months of rigorous testing, right? Like might be the case on Chainlink. Um, and there's folks who want that trade-off matrix, right? There's folks who don't want to just wait for Chainlink to adopt new price feeds. There's folks who want to essentially say fuck it and ride with new prices that might not have the kind of liquidity that those larger oracles would require before they listed price feeds for them. So, for example, this may be your own token. Like in the case of
Right.
Cosmos, if you're launching a chain for your own token, you may not hit the metrics that other oracles would require from you, but you still want oracle fees for your own token, right? So Slinky would be a great like value prop for you, right? Because you're able to sort of control it yourself and have your own price feeds.
Yeah.
And
And
in general, I would say just in Cosmos, like we deal with liquidity numbers that are not what Chainlink and Aave and all of those operators have. So like everything has to be scaled down a little bit.
no, it's cool. Well, I mean, DYDX hits them, but they're separate.
This
Uh,
is true.
yeah. And then I mean, like the other question too would be just this was always a pushback from Vitalik too. Like, would you halt the like let's say Binance and Coinbase both one flash crash is up, the other flash crash is down. You have no idea where the price is on a given coin. You as a validator are not comfortable submitting. Does the chain halt or does the chain kind of continue just without updated prices?
Yeah. So, I mean, at a high level, this is configurable within Slinky.
Okay.
You can have consensus essentially have as a predicate correct Oracle operation. So you can essentially say, okay, well, if this currency pair can't post a new price or something is going on, then we should halt consensus until we can get a good price, right? We'll just halt the state machine.
Right.
Nothing will be executed. Essentially, it's frozen in time until like the Oracle can resume. So this might make sense for perpetuals protocols because DYDX as a chain has one goal and one goal only. It's to essentially give accurate prices and to support the safe trading on multiple different currency pairs. And so the Oracle is almost like it almost should be treated as like a core function of consensus. Whereas if you're building this on top of I don't know, Berachain, right? Or a place where the perpetuals markets and the lending markets are not necessarily the sum total of the entire value proposition of the chain. You may want to have more lax conditions on that. And so what we do believe is um, you should be able to essentially tie the atomicity of certain protocols to the correct operation of, or make atomic the operation of certain protocols with the correct operation of the oracle, but have that be configurable, right? And have that be decided on a chain by chain basis.
Super cool. Um, I know this is a short deep dive. I wish I would. We're gonna have to do it again because I'm gonna have like a million more questions. Right? Who aggregates these would be my question. So like, I guess this is more on just the votes in general. But like, is this the proposer that aggregates all of the vote checkpoints, or like, do you if you did a pre-vote, you have to submit one of these as well? Because like, I was thinking like, if it is optional, like assume we're on one of the optional chains, does the proposer have any sort of control over like I'm not at it, I'm not including your price, the top 10% so I can lower the price and run some MEV on it? Or is that
Yeah. So I guess like to manipulate a median, you need to manipulate half of the values in a certain direction,
yep.
right? So like you can't just
Well, that's what
if
I
you
was assuming.
disregard 10,
Like, I was assuming this is like an optional submit one. So, like, the numbers could be low enough that you're not going to halt the chain by not including them or something.
yeah. So basically, there's like a couple thresholds that you need to hit for certain things that sort of result in this overall security properties of Slinky. So in order to just get an update, you have to get 2/3 of the stake weight behind that
Oh,
update, right? So you have to include 2/3 of the vote extensions. If you don't, then there's
there's no
no
price.
moving forward in consensus, right? The proposal will be invalid. So you have to include at least 2/3. So that's where you're starting from. So if you're looking at this from like an attack standpoint, you'll assume that this evil proposer includes exactly 2/3, right? The bare minimum.
Yep.
Then of that, those prices within those 2/3, it's a stake weighted median. So you essentially have to manipulate 50% of the stake in one direction, which results in an overall stake weight of 1/3, right? Half of 2/3 to like move the price in a certain direction. So without additional checks, that's like the baseline level of manipulation that you need to get to is controlling 1/3 of the stake of the chain to even move the price an inch, right? Otherwise, you can't.
You might be able to move it an inch. It depends on where the distribution lies. You're assuming it would,
Sure, but to
right?
meaningfully control where the price is
Meaningfully.
going. Sure. Yeah, you're right. You're right.
Um,
So that's like the baseline. The proposer does have the ability to select which 2/3 of vote extensions they include. Um, I think over time these things would be relatively straightforward to spot. Like, okay, this proposer is constantly including like the lower end of the spectrum, and
right.
we do have like metrics to evaluate these things. But it wouldn't really it wouldn't benefit them to do this because they're choosing like the 2/3, but um, the network participants are able to essentially see exactly what they're choosing at the same time that their choice is being made, right? Because the proposal is gossiped within the network, and so all the traders can see what 2/3 are being selected. They can optimistically run the aggregation function on it just to like to think through what it might become, and essentially they can all trade on that information as soon as it's live.
Super cool. Um, yeah, so
And
I know
nobody can front run that update because it's guaranteed at the top of the block before transactions get executed.
we're kind of running up on time here, but like how can people like if I was a new chain, do I owe you guys money if I want to use this? Do I just go, like do you guys have a token? Do I just start using the code?
Yeah, so our code is BSL licensed, which means it's source viewable, but it's not open source. And the reason for that is like this is an Oracle. Like we don't want people like just ripping it because it is something that's a very nuanced system. Um, in terms of like when we do hands-on integrations, we generally do charge for our time. Otherwise, we would be out to lunch. And usually, what we try to orchestrate is some kind of, or we try to negotiate is some kind of share of value of the new markets that are launched on top of the system between ourselves and the validators. So we ask the chain to sort of allocate some kind of like new yield for folks that are running this, and like we would take some share of that. So we do try to like align ourselves with the upside of the chains that are using Slinky.
Super cool. Yeah.
But I assure you that it's not chain link type values that we're talking about. I mean, at least from what you told me about $5 million. Oh no,
Yeah.
that was $5 million of liquidity. But
Liquidity.
I think a lot of these oracles do charge a lot upfront.
They do. It's usually seven figures to kind of go to a new chain, but this isn't. No, I've said for a long time that for like chains own tokens, like I think they'll just launch their own Oracle. Like why not?
Yeah.
Your own tokens kind of built in there, but this is cool. Yeah. I guess did I miss anything super critical or?
I don't think so. I mean, I think that's actually a very good high level. I mean, we could of course go into like details about the different consensus steps and sort of like the security properties of each one, what it looks like to run a sidecar, like that whole system. But at a high level, I think this is a pretty good overview.
Yeah, and I love you guys are getting some restaking memes in there. Super good.
I mean, it's literally just a restaking product. Like we didn't intend
Yeah.
for it to be. It just makes sense in this case. Like you have security, just use it to operate your own Oracle and reward and slash based off of that. That's essentially what all of restaking is.
Yeah, no, I know it is, but you know, like most people think about it as something, you know, basically doing these external services or something like that. Whereas this, it's very internal, which is like, but that's when restaking probably makes the most sense. So it's kind of cool.
Yeah,
Um,
it's internal, but it's also external, right? You're running an out-of-band sidecar. You're responsible for a new operation that is not critical to the consensus of your chain, right?
well, it
It's just
might
like
be.
it's something that's new, right? You might believe it is, or you might want it to be, but um, you can extend this paradigm and you can extend the Slinky sidecar to run other out-of-band services with like a similar model.
Cool. Yeah, because you could probably do keeper services, and I'm guessing the IBC things running similar as well. Maybe.
Yeah, you could run IBC relayers as a sidecar. That would fix a lot of problems.
Yeah. Um, anyway, super thanks for coming on. This was a blast and definitely learned a lot.
Yeah, thanks so much. Thanks for having me.